Hi, today I would like to talk about abstract of SMS spam filtering algorithm. The SMS spam filter algorithms focus only on accuracy of spam filters and do not consider the resource consumption of mobile phone hardware. The feather library is designed to store feature conditional probabilities and prior probabilities. The main library update algorithm does not to run immediately and can be run at will by mobile application or copy to the desktop clients as usually. A web-based SMS filtering algorithm running on a mobile phone does little work and does not require a lot of resources. So it can be equally adapted to the changing preference of users. So the experiment showed that the algorithm can improve classifications speed while maintaining high accuracy. And also it takes less storage and can be used on common mobile platforms. So the filter algorithm is divided two, which is the main library update algorithm and the web-based SMS filtering algorithm.
For introductions, SMS spam filtering using naive-based classifiers is a widely used technique to classify text message as spam or legitimate. This approach is based on the naive-based algorithm, which is a simple probabilistic classifier that can be efficiently trained in a supervised learning environment. Spam can be defined as unsolicited emails or messages sent to recipients that users do not want to their inbox. Due to unnecessary notifications and content, spamming has become a nuisance, a waste of time, and a frequent distraction for the recipients, and it has increased in social media. For currently, SMS spam filtering research mainly focus on content-based spam filtering algorithm. Another thing to consider is the difference between text message and emails. So for the text message are short and lack typical information unlike emails. For the traditional content-based spam filtering algorithms cannot be directly applied to SMS spam, but develop an effective SMS spam filtering methods that effectively classifies text message into spam and non-spam.
My name is Siti Adriana binti Muhammad Norazman. My metric number 101063. I will be presenting my part motivation. Our main topic for this assignment is SMS spam filtering. SMS spam filtering is to protect users from this nuisance and potential security risks. Other than that, if followed with our understanding, it can identify and block unwanted or unsolicited text message. Furthermore, we discussed some things that related to SMS spam filtering and search for any machine learning that suits with SMS spam filtering. Although this topic looks easy, it has some challenge in searching for information for it. Next, understanding SMS spam filtering is a challenge and intriguing issues that calls for a combination of technical know-how, imagination, cautious consideration, and privacy. The first thing is to collect a large data collection of SMS message, which include both spam and legitimate known as ham message. This data collection is used to train and evaluate the filtering system. Moreover, after collecting the data, we can continue to complete our project as complete as we can. And the last thing is why this topic is interesting to work on. First, SMS messages are typically short, and this limitation necessitates the adaptation of traditional text analysis techniques, which rely on longer text to identify patterns. For example, SMS messages were 160 or fewer characters. On the other hand, SMS messages are often brief and may lack of context in contrast to emails, which frequently contain more contextual information. Identifying the difference between spam and legitimate message frequently understand the nuisance. Thank you.
Hi, my name is Nufara Hinanit Imran and my number metric is 100554. Today I would like to present about related work, and the related work is SMS spam filtering using the naive-based classifier is highly effective, especially for portable device with limited resources. Key strategies include optimizing the algorithm through offline preparation and online filtering to enhance performance on device with constraints, memory, and processing power. Comparative studies show that naive-based surpass alternatives like SVM and KNN in both precision and efficiency. Its ability to adapt to user preference further improve its effectiveness in personalized spam filtering, making it a robust choice for mobile device. Thank you.
For the implementation part, Python are used in this project to build an SMS spam filter. According to Swapna on 2023, Python is a fantastic tool for this task and easy to use. Machine learning will be used to mark SMS messages as either spam or ham, which is not spam. Getting data. For the implementation part, Python are used in this project to build an SMS spam filter. According to Swapna on 2023, Python is a fantastic. First, we import necessary libraries and modules. Python modules are groups of reusable code like classes that boost Python's features. Pandas is a data analysis module that shows this ability. In Python, importing modules and libraries grows utility and flexibility. These tools allow smooth integration with other tools, making tasks like performance simulation with real-time data easier. For the second step, we load the SMS spam collection dataset. We use pandas to read a file containing messages labeled as spam or ham in order to import the SMS spam dataset into Python. By making a model that properly spots spam, this process helps reduce the risk of identity theft and financial loss. Next, we feature extraction. Python feature extraction turns raw data into features that are useful to machine learning. Picking the optimal features for a model's training is known as feature selection. For PCA and LDA methods, use pandas and scikit-learn. Next, we split the data into training and testing sets. In Python, split a dataset into training and testing sets. The machine learning model learns with the training set. The testing set used to judge the result of the model with new data. Graph algorithms can be used to split sequence data in order to build deep benchmark datasets. Next, we train a naive-Bayes classifier. Naive-Bayes classifiers predict with trait likelihoods and presume feature independence. Accuracy, sparsity, and runtime of a sparse naive-Bayes classifier are great in balanced datasets. Unbalanced datasets, it accomplishes a balance in classification rates. Next, we make predictions. Python predictions forecast values or results based on new inputs using a trained model. For tasks like protein structure prediction, image segmentation, hierarchical labeling, multi-level classification, and classification, prediction sets gives easy, precise distribution-free error control. Next, we evaluate the model. Utilize a model in Python for its accuracy and use to new data. Make use of usual metrics, measurements, and data and model comparisons. Evaluate library helps the evaluation process and raises reproducibility. Lastly, we test the classifier with user input. Rather than training the classifier on a dataset, in Python, testing the classifier with user input involves applying the trained model to make predictions using user-provided data. Due to its discord, the CLI of the current software is hard to use. It lacks the use of new methods like deep learning or word embeddings. Also, a graphical user interface (GUI) that might boost user interaction is absent. Its bound daily practicality also stems from its failure to sort SMS messages in real time. For overcoming difficulties in implementation, it's vital to boost model accuracy by text preprocessing. We chose TF-IDF vectorization for its efficiency. It's hard to pick the best model, but we went with knife bayes for its ease to use and strong text classification. It was hard to get a balance in recall and precision, so we altered the model's parameters. For the assessing software performance, the software does well, identifying spam with no errors and about 98% precision and recall on test data. It can be used alone or in alongside advanced tool and is dependable tool for dividing SMS messages as spam or ham. For evaluating accuracy in specification satisfaction, the software gets high accuracy, precision, and recall by accurately classifying SMS messages based to their content. Since it lacks graphical user interface and advanced features, it runs well and gives a solid base for updates in the future.
In conclusion, this project marks a significant advancement in managing unsolicited messages on mobile device by balancing accuracy with minimal resource consumption. We address the unique challenges of SMS spam filtering, such as the brevity and unstructured nature of text messages. Through a meticulous process involving data preprocessing, TF-IDF vectorization for feature extraction, and the application of the multinomial knife-based classifier. Our result shows high accuracy and efficiency, with the algorithm maintaining high classification speed while being adaptable to changing user preferences, all within the limited hardware resources of mobile platforms. However, there are areas for improvement. The current implementation lacks a graphical user interface and a real-time message sorting. Future enhancement could include advanced text analysis techniques like word embeddings and deep learning models, as well as a user-friendly GUI for better interaction and real-time processing capabilities. In conclusion, our project combines a classical machine learning techniques with thoughtful design tailored to mobile device constraint, offering a reliable and efficient solution to SMS spam filtering. In this part, I will guide you through a step-by-step on how to run our program code using Jupyter Notebook. So step 1, you can install the necessary Python libraries using pip by opening your terminal and type the command above. As you can see, I have downloaded the necessary Python libraries. And for step 2, we are going to open Jupyter Notebook by running the following command in the terminal. This will open the Jupyter Notebook interface in your web browser. Next, navigate the location where you save your Python notebook file and open it. Ensure that your dataset is in the same directory as your notebook. Now you can run the code, and this is the review of the output. You can test the model with user input. For example, if the user enters the message, the model will classify it as spam, and the output will be the message is spam. Similarly, you can run the program again and try it with something that you would text your friend, and it will give the output that it is not a spam. That is all for this part. Thank you for watching.